Welcome to the Studio of Simplified EGD, your go-to learning space for mastering engineering graphics and design.
Welcome to the Studio of Simplified EGD. Today we are going to learn about Focus and Directrix method. Focus and Directrix method is used to draw ellipse, parabola and hyperbola. If it is given that the eccentricity is less than 1, then the curve will be ellipse. If your eccentricity will be equal to 1, then it is parabola, and if your eccentricity is greater than 1, then it will be hyperbola. Now how this eccentricity will be work and what is eccentricity, that we are going to see. In engineering curves there is a fixed line, okay, so that fixed line is called directrix. That fixed line is called as directrix. The perpendicular line to the directrix is called as axis. It is perpendicular to the directrix, and a fixed point, let's say at a distance of 50 mm. A fixed point in engineering curves is called as focus point. Okay. Now suppose there is a point P that is traveling and this is a locus of point P. Locus means point P is traveling through this path, okay, that is called as locus point. P point is traveling in such a way that, let's take this point, in such a way that its distance from focus and its distance from the directrix line, okay, will be kept constant. Its ratio will be constant, means this distance and this distance might be same or might be different, but it will be constant. Its ratio will be constant, not distance, its ratio will be constant. Let's take point P1, F and D1. When your curve crossing the axis, the point we are getting here, that point is called as vertex. Okay. Now eccentricity E is equal to P1F upon P1D1, means eccentricity is a ratio of the distance from point P to the focus to the ratio of point P to the directrix. This ratio will be kept constant and point P is traveling, and if these both distance are same, means let's take 30 mm and 30 mm, so 30 by 30, that is equal to 1, means your eccentricity will be 1. Eccentricity is 1. When your eccentricity is 1, your curve generated will be called as parabola. Okay. Now suppose there is a point P which is traveling in such a way that its distance from focus is higher than the distance from the directrix. Let's take D2 point here, means E is equal to P2F upon P2D2. This distance is higher, okay, P2F is higher, means the value will be greater than 1, means your eccentricity is greater than 1. When your eccentricity is greater than 1, it is called as hyperbola. So this curve is hyperbola having eccentricity greater than 1. Here your curve name is parabola having its eccentricity E is equal to 1, and there is another curve, another path, this is V1, V2 and V3, traveling point P in such a way that its distance from focus is less than from the distance from directrix, means your eccentricity E is equal to P2F upon P3D3. P3D3 is higher, this value is higher than this value, so its total value is less than 1, means your eccentricity will be less than 1. On that time, curve generator will be your ellipse. Okay, so here your curve generated will be something like this. It's vertex v3 and v4, as well as ellipse has two focus, f1 and f2. It is your ellipse having eccentricity less than 1. Okay, when your eccentricity is greater than 1, your curve will be hyperbola. If your eccentricity equal to 1, then curve generated will be parabola, and eccentricity that equal to 1, sorry, less than 1, then your curve will be an ellipse. Now let's see an example of focus and directrix method. Draw the locus of point P which moves in such a way that the eccentricity ratio is equal to 2 by 3. First of all, we will write given data in which eccentricity E is given as 2 by 3, which is less than 1, means our curve will be an ellipse as we have seen earlier. Okay, the fixed point means focus point, okay, is 30 mm away from a fixed straight line. Fixed straight line means directrix. Okay, means the distance between directrix and focus is given as 30 mm. Okay, then first of all we will plot a directrix. Okay, draw a directrix, means vertical line, that is called as directrix. Leave some measurement on upper side, then take a small measurement, take a perpendicular line, draw a perpendicular line, give the name origin here. This perpendicular line will be an axis of the curve. Here ellipse is going to be generated. Okay, ellipse will be like this. This is major axis, minor axis. This point is our vertex 1, vertex 2. Here it will be focus 1 and focus 2. Okay, so focus, this distance is given from the directrix, that is 30 mm. So we first of all plot 30 mm distance and focus point f1, focus f1. Now eccentricity is 2 by 3. Okay, means P point is traveling in such a way that 2 unit measurement from the focus side and 3 unit measurement from the directrix side. So what we will do, this is point P, travel path, focus, and that fixed point measurement is 2 units and this measurement is 3 units. Here also 2 units, 3 units, so total it is 5 units. 2 plus 3, that is equal to 5. So we will divide this OF measurement into 5 equal parts by using division of line method. Draw a line which is having the angle less than 90 degree. Take a small measurement on your rounder. And draw 5 arcs, as we need to divide this into 5 equal parts, 4 and 5. Connect the fifth arc with focus f1, and draw parallel line from each arc. Okay, so we have divided this OF1 measurement into 5 equal parts. So eccentricity E is equal to 2 by 3, 2 measurement from focus, 0, 1, 2. This is our vertex V1, okay, and this will be automatic 3, 0, 1, 2, 3 division. Now parallel to directrix, draw a vertical line from the V2 point. Then take a measurement of V1 F1 on your rounder and draw more than half circle which will intersect the vertex V at 2 points, upper point and lower point. Draw a straight line from origin and upper point as well as from the lower point, from origin to the lower point, okay. Now for the vertex V2, for this vertex V2 we will plot 45-degree line from the focus point. So take a measurement of 45-degree from the focus point, 10, 20, 30, 40 and 45, okay. This line will intersect the earlier line which is coming through origin at a particular point. We will draw perpendicular line from that end point and give name as V2, vertex V2. So in between V1 and V2 our ellipse will be generated. Now take any small or random measurement. You can take this much portion also, or you may take 1 centimeter or as per requirement, any random measurement. Draw arcs and divide V1 V2 line into several parts. The numbers of division higher, that will give the more accuracy of the curve. More division, more accuracy, okay. Now draw perpendicular line from each arcs to the axis. एक्सिस के साथ 90 डिग्री बनना चाहिए. सो डायरेक्ट्रिक्स से पैरेलल हर एक आर्क में से लाइन ड्रॉ करेंगे which will pass through more than this distance, okay. दोनों ये ओरिजिन में से जो लाइन निकल रही है उससे बाहर जाना चाहिए. गिव द नंबरिंग 1 1 डैश, 2 2 डैश, 3 3 डैश, 4 4 डैश, 5 5 डैश, 6 6 डैश, 7 7 डैश, 8 8 डैश, okay. Now with your rounder take a measurement of 1 1 dash, put your rounder on focus and draw arc on 1 1 dash line. Put on focus, draw arc on 1 1 dash line. Measurement of 2 2 dash, take a measurement of 2 2 dash, put your rounder on focus, draw arc on 2 2 dash line. Take a measurement from 3 3 dash, put your rounder on focus, draw arc on 3 3 dash line on upper side and lower side. Take a measurement from 4 4 dash, put your rounder on focus, draw arc on 4 4 dash line. Measurement from 5 5 dash, put your rounder on focus, draw arc on 5 5 dash line. Measurement from 6 6 dash, Put your rounder on focus. 6 dash line. Take a measurement from 7 to 7 dash. Put your rounder on focus. Draw arc on 7 dash line. Put your rounder on 8 dash. Take a measurement of 8 dash. Put your rounder on focus. Draw arc on 8 dash line. Give the numbering to each arc: P1, P2, P3, P4, P5, P6, P7, P8, P9, 10, P11, 12, P13, P14, P15, 16, P17, P18, P18, okay, and P19. This, and draw a smooth curve from the vertex here. You have to consider that, take a note that here it is your focus point. So in a line, vertical line, your curve should touch these two lines on upper side and lower side. Your curve should be passed in such a way that these lines will make a tangent. Okay, draw a smooth curve. At the focus it will touch. Okay, here your curve is generated. Give the name to the curve. Ellipse. Give the dimension which is given. We have dimension from the directrix to the focus, that is 50 mm. Okay, now for the tangent and normal to the curve, take any point M. Take any point M on curve. Connect this M point with focus F. Okay, and draw perpendicular line, or you can measure 90 degree. Measure 90 degree from the focus. 180 on this side I am going to measure, and draw a straight line which is passing through focus and intersect this directrix. The intersection point will be T. Now from T and M, draw a line that is called as, give name TT dash, that is your tangent, and perpendicular line will give us NN dash, that is normal.